Hello, this is Mrs. Spy, and let's go over what a fractional exponent is. So if you get 25 to the 1/2 power, it's the same thing as the square root of 25, which is 5. Same thing, get 121 to the 1/2 power. It's the same thing as the square root of 121, and that equals 11. Let's keep on increasing the denominator and look at it. So let's say we increase the denominator to 1/3 or 1/4. So we had 8 to the 1/3 or 81 to the 1/4. So 1/3 is asking me what number times itself 3 times to give me 8, or what number in this case would be 4 times to give me 81. What number would be 3 times to give me 8 is 2. 4 times to give me 81 is 3. And you can go really big. Let's say we had 256 to the 1/8 power. That's the 8th root of 256. And you take out a calculator and figure out, 2 times 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 2, 8 times, will give you 256. Okay? So where does this come from? Why does this work? Why does this work? Well, the main idea is imagine someone asked you what 16 to 1/2 power is, or what 4 to the 1/2 power is. 4 to the 1/2. And based on what we're telling you, it's the square root of 4, which is 2. Now, we want to think, what would happen if I square this? Because 1/2 times 2 is 2 over 2, or 1. So if I square it, I get 4. So what number gives you back what you started when you square it? Well, that's a square root, because the square root of 4 squared is just 4. So that's what a 1/2 power is, and that's the reason we define it as such. Now, what happens if the numerator is not 1? Let's do a few examples of that. What happens if the numerator is not 1? Let's say we had 16 to the 3/4 power. So the easiest way to do it is to break up the exponent with the 1/4 on the inside and 3 on the outside. What number times itself 4 times 16? That's 2. Raised to the 3rd power, get 8. You also could do it the reverse way. Say we had 8 to the 3/2 power. That means you could do 8 to the 2/3 power. Don't want to get a decimal yet. So that'll be 8 squared raised to the 1/3. So that's 64 raised to the 1/3, and that equals 4. It's your choice which order you do it in. I prefer the one I did in black ink because it's easier to work with smaller numbers than larger numbers. Okay, let's look at one example of a negative exponent, and then we'll wrap up this video. And then the next video, we'll look at what happens if we were to make x as our base and how to work with it. So let's do one negative example. So let's say you had 32 to the negative 8/5 power. So that'll be, you break it up, 32 to the 1/5 power to the negative 8. And then 32 to the 1/5 power is 2. 2 to the negative 8 is 1 over 2 to the 8th power. If you take out a calculator, 2 to the 8th power is 256. So it's 1/256. You don't want to write these as decimals. No decimals usually. Most teachers don't want to see decimals. I would not want to see decimals if I was your teacher. No decimals. Okay? Hope this was helpful to know what a negative exponent would be when it's a fraction. Also, how to work with fractional exponents and what do they mean. And to review in basic ideas, let's do one basic rule using the definition. Which is as follows. One basic rule using the definition. And I'll write out the definition the way I like to write it out. If you have x to the n, x to the n over d, same thing as the dth root of x to the n. So let's do one example. You have 16 to the 3/2 power. That's the square root of 16 raised to the 3rd power. So the square root of 16 is 4. 4 raised to the 3rd power is 64. Let's do another example before we wrap it up. Let's say we had 81 to the 3/4 power. That's the 4th root of 81 to the 3rd power. 4th root of 81 is 3. 3 to the 3rd power is 27. Hope that video was helpful. This is Mr. Spy signing off. Have a great day, everybody.